Hi everybody, I'm Tony E at Show IP Interface Brief, and I wanted to give the answers or the explanation to the challenge. This is the drawing topology. We have our four routers, router 1, router 2, router 3, router 4, with our connected interfaces. They can all reach each other all in the same broadcast domain, and each of them has a loopback. This is my GNS3 topology. All routers interfaces must be configured using the IP schema. Okay, they should all match. You must run RIP protocol between all routers and no other routing protocol. Advertise your connected networks. So I'll use the network statements, and just by habit, I always type the exact interface IP address, which is not necessary here using RIP. All right, advertise all your connected networks. So let's go ahead and do on router 1, show IP route, and verify we're seeing some routes. We're seeing our own 1, the 2/8, this 3/8, and the 4/8. Router 2 must run RIP version 2. While we're still in the router config, let's go ahead and do version 2. And all other routers must run RIP version 1 and should see router 2's loopback with its real mask. Okay, so the whole point of this lab is not to stump anybody. This is not an overly complicated lab. There is no trickery here. I was actually doing it, and that's why I'm running RIP protocol here. It's sort of a back to basics approach. I found that I was getting so deep in the weeds with configurable options on QoS and here's some for VPN that we're going to finish this lab with, that I was sort of forgetting some of the basics, and some of the basics go back to RIP. Right, so this one here is what caught me initially. All other routers must run RIP version 1, which they are, and they should see loopback, router 2's loopback with its real mask. What is the real mask of loopback 2? It's a /32. Let's go over here, show IP route. There is no change. This was updated 20 seconds ago. So what do we have to do to be able to see that change? We got to turn off auto summary. So on all of our routers, let's do no auto. We might have to wait for RIP to rebroadcast. Otherwise, we can no shut its interface. Here we are in a lab, so that's fine. So I'm going to shut the interface. And do a no shut. That should, the RIP protocol should then re-advertise its networks, and we should see that over here. Good. So we are seeing the new /32 as advertised by RIP 22 seconds ago, and this /8 is no longer being advertised by router 2. Instead, it is timing out. So if we did continue to do a show IP route, we'd see that go all the way up to 3 minutes before it gets removed. Okay, so let's go around the table here and make sure all of them are seeing the same routing table. Good, so this is router 3. He sees his local 3s, a classful 4, a classful 1. He still sees that classful 2. That is going to time out, and he does see that /32. Router 4, we'll show the routing table, and again, the classful 1, we are seeing both the routes for the 2 network. One of them will time out at the 3-minute mark, 3 and its own 4. Now if we go over here to router 2, show IP route, what happened? So why aren't we seeing any routes from the routers here on router 2? That's because router 2 is now running RIP version 2. But wait a second, all the other routers get to see router 2's prefixes. Why doesn't router 2 get to see router 1's prefixes? To show that, we're going to do show IP protocols. For example, routing protocol is RIP, and here's what we want to see. Out of our fast Ethernet interface, we are sending RIP version 1 updates, but we'll receive version 1 or version 2 updates. If we come over to router 2 and we do show IP protocols, we see out of our fast Ethernet 00, we are sending version 2 updates and receiving version 2 updates only. So that means we're sending our prefixes with our subnet mask over to routers 1, 3, and 4, and they're receiving it. But router 2 is never going to accept the version 1 RIP updates. It says you must have routes representing all the subnets class full or better from the topology in your routing tables. So we have all of them in 1, 3, and 4. So how do we get router 2 to accept the version 1 updates? That's at the interface level. So let's go into interface, do IP RIP, receive, and if we do a question mark, we can do version, and we can do 1 space 2. Enter. Now if I do a show IP protocols again, you can see here for our fast Ethernet 00, we're now receiving 1 and 2. To verify we have some routes in the routing table, we see we've already got populated with router 4's network. It's classful as router 4 is advertising it. And there's 2. We are 2, here's 3, and router 1 is there. Excellent. So now we've done 1, 2, and 3. So again, this was a back to basics approach. This was no hidden commands or anything like that. It was just a fundamental understanding of some protocols. Okay, configure GET-VPN between all routers' WAN interfaces. Router 1 must be the key server. So I have a little template that I have built. So I'm just going to copy and paste that in to save time. These configs will be on the blog site. You can get them from there. So the same template that I did for the group member, I can paste that on all 3 of them, and they will all reach out to the key server to get their information. I wanted to point out that in my template, I did have an access list up here, access list extended 100, that's permitting ICMP any. Okay, pings sourced from loopbacks of group members to other group members must be encrypted. All other traffic should not be encrypted. Let me come over here to router 4. I'm going to ping, I'm going to ping another group member. Okay, that was good. We can do show crypto GDOI. And it's going to give us some information about that group association. Let's ping also router 3. Excellent. Let's try to ping router 1. And that's failing. So again, this is not trickery, it's just a fundamental understanding of the protocols and the design. The group members do not have a security association, data plane security association with the key server. They only have it with each other, the group members. So in this case, router 1 was the key server, and router 2, 3, and 4 are the group members. So I'm going to go ahead and open Wireshark. Okay, we've configured GET-VPN between all the routers, and router 1 is the key server. Let's move on. Ping sourced from the loopback interface of group members to other group members must be encrypted. All other traffic should not be encrypted. So again, let's do the ping. I'm going to go, I'm going to ping 2 to 4, and you see those ping packets are being encapsulated. all other traffic should not be encrypted. Okay, so let's go back a moment to pinging 1.1.1.1, and let's source it from our loopback on router 4. And if we watch Wireshark, you can see that those pings are being sourced from router 4's loopback, destined for router 1's loopback, and they are being encapsulated. Now, why are they being encapsulated? If we take a look at crypto, our access list is permitting ICMP any. So that means any ping traffic sourced from this box is going to get the encryption. But we don't want to get the encryption applied to any packets heading for router 1, or else they're going to fail and I'm never going to get a response because router 1 does not have a group security association between the group members. Let's come over here and do show run, pipe include access list. Let's get the access list number and we'll show that access list. Show access list 100. Okay, we see this is extended access list. It has a single entry which is permit ICMP any. My way to get around this was to do IP access list extended 100, and let's put an entry as number 9, which will go right before that. And let's do deny any to host, deny IP any to host 1. Now I've just updated that access list, so I get this alert message which says that the policy has changed and I need to update it. So I'm going to go ahead and copy the command, run it here. We should see on router 4 we're getting a couple of alert messages down here. Okay, so now let's check the crypto. Here we go. Now we see the ACL has been updated. Deny IP any to host and permit ICMP any. Let's go ahead and send those pings again. And here we are. We see it in Wireshark here in the background. Those pings were successful and they were not encrypted. So we did ping from loopback to loopback from the group members, and that was encrypted. So ping 2.2.2.2 source 4.4.4.4. That is being encrypted. We can see that. So let's do telnet 2.2.2.2 23 source interface loopback 4. And I just wanted to see that the TCP and the telnet traffic was not being encrypted, so we can see that in Wireshark. You should have full reachability to all loopbacks in the topology. For that, I went ahead and did a TCL script. And I'll include this. So now I can ping everybody. When I'm pinging 2, 3, and 4, which is myself, it should be encrypted. When I ping 1, it will not be encrypted. Okay, so we could go around the table. And we should have good results. Okay, so that's how I solved this challenge. That's the at least the intended path that I meant when I designed it. Again, this was not a stump the chump exercise. This was just a back to basics approach so we can sort of revisit some of those older technologies we might have lost along the way. I hope to produce a couple more challenges. I always have a lot of fun. Let me know what you guys like. You can leave me some feedback below.